Welcome to C# for Crestron programming.
In this video, we will be examining the concept of checking if the appliance running our program supports the communication we require. This is a critical step when designing singular programs to be loaded on a variety of products or virtual controllers. We will be starting with a C#.NET Framework class library project called Checking If Supports. At this point, our NuGet Crestron program package has been imported and the original class1.cs file removed. All of our reference.dll files are included in the NuGet import, so we will simply add the using statements for the hardware we need in our program. Using crestron.simplesharppro.ui.thermostats and .keypads. Within the control systems class, we declared objects of types we need, but will instantiate them later on in the program. In this example, there is an Ethernet touchscreen, CrestNet keypad, and a wireless thermostat. When you look around in the available namespaces, you will see that the following selection of onboard I/O is available to declare. We declare these objects at the class level so they are available to all methods within the class. However, these more base declarations will not be able to perform any actions themselves without being related to a numbered physical port. We will see this shortly. While most processors have a common range of communication types they support, there are differences between the hardware. Best practice before creating code that relies on a communications medium is to ensure that the processor does in fact support that method of communication. Within the try catch of the default control system constructor, we will begin checking. Here is code to instantiate and register our Ethernet touchscreen. While there is error reporting on registration, we have not yet completed any check that Ethernet itself is supported. A simple if-else wrapper will accomplish this for us. And we will use the syntax of if this dot supports Ethernet. The keyword of this refers to the class we are currently inside. In our example, we are inside the control system class, and are therefore referring to the processor itself. With the current range of processor offerings, checking for Ethernet seems superfluous, but these checks are increasingly important with other communication protocols. We were able to check for CrestNet support before adding a device to a VC-4 program, as it would not be directly supported, and so on. Internal RF gateway support checks are critical for hardware-based processors with InfiniteEX devices in the program. COM port support can be checked prior to attempting to register a COM port for the program, and here we are using the optional base device of my COM port declared at the top of the program to simplify naming of the port. While the COM port support check may pass, that does not guarantee availability of that particular COM port. Since it is not a shared resource across all processor program slots, it would be good practice to also check if it has already been registered prior to attempting registration. Once registered, the COM spec can then be applied. All physical onboard I/O can be directly accessed without instantiation or simplifying the name. IR input or output support can be checked. IR ports are shared, but do not require registration. The .ir file is loaded directly to the port. Relays are a shared resource, but still require registration. Checking for your type of I/O is important as processors vary as to their support of VerSupport or basic digital I/O. Once you have determined that VerSupport is supported and your port is registered, you then set the VerSupport config. These and many more checks for support are included in the hardware programming options. You have now seen that checking for support for a communication medium before attempting to access that medium can be an important component of creating programs to support multiple processor types.
Thank you for watching.